everyone, I'm Heidi Postle. Welcome back to A+ Maths. Today I'm going to be doing quadratic equations. Now, quadratic equations normally come in the form ax squared plus bx plus c equals 0. Then they can come in many different ways, and we're going to look at each one separately so that you know what to do. Let's have a look at question number 1. X squared equals 16. What do? We need to square root both sides to get rid of the squared. So we square root both sides, and what are we left with? X equals plus or minus 4. Don't forget your plus or minus, because 2 times 2 can equal 4, and minus 2 times minus 2 equals 4. Question 2. X squared equals 81. Again, square root both sides, and you're left with x equals plus or minus 9. And that means 9 and minus 9. Question 3. X squared plus 5 equals 41. Now we need to take away 5 from both sides, so we get x squared equals 41 minus 5, which is x squared equals 36. And then square root both sides, and bingo, x equals plus or minus 6. No problems. Pretty simple so far. Let's have a look at one more style. Question number 4. Type 2 is with brackets. Our first example is x minus 1, x plus 2 equals 0. So here we have a problem. What are we going to do? There's no squared, so we can't square root both sides. But what we do know is that 0 times something equals 0, and something times 0 equals 0. So we can let one of the brackets equal 0. So we're going to have two equations. Either x minus 1 can equal 0, or x plus 2 can equal 0. And then we solve each one. X can equal 1, or x can equal minus 2. And we're done. Let's take a look at another one. They're pretty simple so far, aren't they? Question 5. X plus 3, bracket 2x plus 3 equals 0. We either have x plus 3 equals 0, or 2x plus 3 can equal 0. Now we solve. X equals minus 3, take 3 to the other side, or we have 2x can equal minus 3, and then divide both sides by 2, x equals minus 3 over 2. Again, pretty good. Question number 6 is type 3. This is when you have a perfect square. Y minus 4 all squared equals 25. We can square root both sides, and then we can get y minus 4 equals, don't forget your plus or minus 5. That brings us to two equations. Y minus 4 can equal 5, or y minus 4 can equal minus 5, the plus or minus 5. Then we just solve each one. So we add 4, we get y equals 5 plus 4 is 9, and we can add 4 to the other side and get y equals minus 5 plus 4, which is y equals minus 1. Question 7. This is also a perfect square, but this time we have a 3 out the front. So the first thing we have to do is to get rid of that 3. So if we divide both sides by 3, we get k minus 2 all squared equals 9, and then we square root both sides. Again, we have our two equations, k minus 2 equals 3, or k minus 2 equals minus 3, and then we solve both sides. K equals 3 plus 2 is 5, and k equals minus 3 plus 2 equals minus 1. Question number 8. These are the ones that you need to factorise first. So let's have a look at one. X squared plus 7x plus 12 equals 0. We have an x squared, we have an x term, we have a constant term, and of course, as it has to, it equals 0. Now we need to factorise first. So we're looking for a number that multiplies to give 12 and adds to give 7. What do we get? What multiplies to give 12? 4 and 3, 12 and 1. Good. Now which one of these can add to give 7? 4 and 3. Perfect. So we can write down x plus 4, x plus 3 equals 7. 4 plus 3 is 7, and 4 times 3 is 12. We have two equations, x plus 4 equals 0, or x plus 3 can equal 0. And then we solve each one. X can equal negative 4, or x can equal negative 3. Another factorising one. Let's take a look. Make sure that you get the hang of it. X squared plus x minus 20 equals 0. Remember, it has to equal 0. Now we're looking for something that multiplies to give minus 20 and adds to give plus 1. Don't forget the 1, there's a 1 in front of the x. So we're looking at 5 and 4 is 5 times 4 is 20, 20 times 1 is 20, and 10 times 2 is 20. Which one of these can give us plus 1? 5 and 4, very good. 5 take away 4 is plus 1. So we have x plus 5, x minus 1 equals 0, because 5 minus 1 is 4. X plus 5 can equal 0, or x minus 1 can equal 0. And then we solve each one. X can equal negative 5, and x can equal 1. Again, we have two equations. Because of the x squared, we have two answers. Another factorising, x squared minus 9x plus 18 equals 0. We're looking for two numbers that multiply to give 18, add to give 9. 9 2s are 18, 18 and 1, 6 and 3. How can we get minus 9 from 6 and 3? Minus 6 minus 3 will give me minus 9. So we write it down, x minus 6, x minus 3 equals 0. And then we have our two equations again. X minus 6 can equal 0, or x minus 3 can equal 0. And then we solve each one. X can equal 6, or take the minus 3 to the other side, it becomes a plus, and x equals 3. Sometimes when you have factorising, you have a number out the front. This is our coefficient of a. Here we have 3. Now, do you remember how to factorise? We have to multiply the 3 and the 12 to give us 36. Now we're looking for a number that multiplies to give 36 and adds to give minus 5. 9 4s are 36, 18 2s are 36, 6 and 6 is 36, and 36 and 1. Which one adds to give 5? 4 and 9. Minus 9 plus 4. So, do you remember how to do this? You got 3x all over 3, and then you've got 3x minus 9, 3x plus 4 all over 3 equals 0. Now, you can't have a fraction when we're factorising, so we need to factorise out one or both of the brackets on the top so that the 3's cancel. 3 bracket x minus 3, 3x plus 4 equals 0. The 3's cancel, and I'm left with x minus 3 can equal 0, or 3x plus 4 can equal 0, and then we solve them. Take the 3 to the other side, you're left with x equals 3. Take the 4 to the other side, 3x equals minus 4, and divide both sides by 3, and we're left with x equals minus 4 over 3. We'll continue doing quadratic functions again, and I'll do a lot more examples. Thanks for watching. Don't forget to like and subscribe.